to multiply these now. F times G. Well, here's the great thing. It's just x cubed, that's a cubed, times square root of x plus 1. You can't do something crazy like this doesn't multiply inside because they're both not radicals. Does that make sense? So essentially, that's your answer. X cubed times square root of x plus 1 with a domain of what? Basically what we're doing there is we're just picking the most restrictive domain between the two functions. Alright, this will be the most challenging one. We have now f. They wrote it sideways. I like to write mine vertically, divided by g. So here I'm going to have the x cubed over square root of x plus 1. Now, pay attention. This one in the restrictive domain says include negative 1. Class, negative 1 plus 1 is?
0.
Square root of 0 is?
0.
Anything divided by 0 is?
0.
Undefined. That's bad. So, our domain in this problem is, should we include negative 1? No, this is a parentheses, negative 1 to infinity. Because if you had to set this algebraically, you're basically setting all of that has to be greater than 0. Do you see the difference? So this is our answer here. Try number 3. Here, this one does not say f of g. It doesn't have the open circle. This is multiplication. Sometimes you'll see it written like this, f and then g. Our function of f is 2x plus 1, and g is 4x squared minus 1. Well, here you have a binomial times a binomial, and in this situation, you're going to either use FOIL or the box. Let's do the box together. I have 2x plus 1 and 4x squared minus 1. Class, what's 2x times 4x squared? 2x times negative 1. 4x squared times 1. 4x squared. And 1 times negative 1. And then inside the box we combine like terms. We write them in descending order. Which one goes first, class? 8x cubed plus 4x squared minus 2x minus 1. Again, you look for the most restrictive domain. In this case, they are the same, so we can just write domain of any value you want. And that's our answer. I have 2x plus 1 over 4x squared minus 1. Just like our rational functions, you probably would want to look at it if you can cancel. In this case, we can't factor nor cancel. But you want to look at our denominator. Am I going to set that not equal to 0, greater than or equal to 0, or greater than 0? Because there is no square root in the denominator, in this problem I'm going to set it not equal to 0. Class, how do you solve for x? Add 1. Now what? 4x squared is not equal to 1. Divide by 4. x squared is not equal to 1/4. Be careful, be careful. Square root. Remember, when you take the square root of an equation, you have plus or minus now. This is really the square root of 1 over the square root of 4. Class, square root of 1 is? Square root of 4 is 2. What is our answer? Ooh, I just saw it. You can factor this one. Ooh, that one's hard. This is 4x squared plus 0x minus 1. If you factor it, it'll come out to be to 2x plus 1, 2x minus 1. So in this problem, you can cancel it. Be careful, there's a 1 up here. So this is our grand answer. 1 over 2x minus 1 with a domain of all values of x such that you can pick every single x value except for positive and negative 1/2. So again, rational functions are the trickiest. I'm not sure. I don't think I'll give you a problem where you have to factor. That was kind of hard to see. Okay, so f is just x squared times the square root of x plus 1. Don't think you could do something crazy like distribute inside the radical sign. It's not possible, so this is actually just your answer. X squared, square root of x plus 1, with a domain of what? Raise your hand if you got that. Alright, this is the tricky one. Ready? F divided by g is x squared over square root of x plus 1. But here, you should be thinking about a rational function. A rational function basically says we do not want this equal to 0, correct? Okay, then you have to think about which problems do I not want to be equal to 0. So in this problem, pay attention, I'm going to set that equal to what? Your choices are not equal to 0, greater than 0, or greater than or equal to 0. 5 seconds, talk to your partner. Okay, raise your hand if you said not equal to 0. Greater than 0. Greater than or equal to 0. Okay, look. Now, I know we did this problem above and we said greater than or equal to 0. But that means that it's okay if this is equal to 0 underneath the radical. Yes? Do I really want this equal to 0? Because what's the square root of 0? And anything divided by 0 is? Bad. Undefined. Does that make sense? So here you're going to make it greater than 0. Subtract 1, you'll get x is greater than negative 1. On a number line, it looks like this. Sorry, that should be an open circle. And so your answer is this, with a domain, pay attention, parentheses, negative 1 to infinity. The reason why this problem is a parentheses and not a bracket, just think about it. If you picked negative 1, class, what's negative 1 plus 1? Square root of 0 is 0, undefined, bad, right? That's why we're not including negative 1.
I love math. You don't love math? What's wrong with you?
All right, question number 9 says f of x and g of x, we have to do these math operations. It's telling us to multiply. And when I multiply these two, let's call this the green. So f, put it over here, f of x times g of x, blue. Then f of x is 3x plus 1 times g of x, which is 3x minus 2. And then I'm just going to transfer these over here. And then I'm just going to multiply here. 9x squared, negative 6x, 3x minus 2. So first we multiply, and then we're going to add or combine like terms. Let's put that in a different color. So these two are like terms, not dark enough. So if I combine like terms, my answer is going to be 9x squared minus 3x minus 2. Box your answer.
Number 6 says find f divided by g. So you have this expression, all you have to do is 3x plus 1, do your substitutions for f, and then your substitution for g, and you have this, okay? I give you partial credit if you did something like crossing off or trying to simplify. You can't simplify those because there you have, these are plus and minus. They would have to be multiplication in order to cancel. Well, you also need to include, you got a point marked off if you did not show me, if you did not set 3x minus 2 not equal to 0, because remember, if you put in there, there's a number in there if you put it in, which is 2/3. If you put 2/3 in there, you have 0. So any number divided by 0 is undefined. So you had to include x is not equal to 2/3. Question 6D says find the domain of f divided by g. So if you did that, you realize that you could pick any number except for 2/3. So here is my interval notation that shows me you can pick any number except for 2/3. And number 6C tells you to multiply because there's no math operation between them. So I have 2x minus 5 times x to the third, and you're going to kind of do this backwards distributing here. So that becomes 2x to the fourth minus 5x to the third, and then with the domain, negative infinity to positive infinity. So basically in the function of f, you can pick any values, and function of g, you can pick any values. So when you're doing some adding, subtracting, multiplying, dividing, you pretty much can pick any of the numbers, except when you do division. So let's do division. F of x divided by g of x, so that gives us 2x minus 5 over x to the third. Now don't do anything crazy like canceling there, that'll be incorrect. Now our domain here, we can find algebraically of our rational function here by setting it not equal to 0. Well, finding the cube root, any 3 identical numbers that multiply by 0, x cannot equal 0. So when we're writing our domain, it's our f divided by g is 2x minus 5 over x to the third, with a domain of negative infinity to comma 0 union with 0 comma infinity. Basically that's just a fancy way of saying you can pick any value except for 0. This one here is f times g because there's no math operation, so f is x plus 2 and g is x cubed. So here I'm going to be multiplying. I get x to the fourth plus 2x to the third with a domain. Most restrictive would be, well, they're both the same, so you can just pick that. And f divided by g here, so I have x plus 2 over x to the third. Remember, don't do anything crazy like canceling the x's, because this is not a factor, this is added. That basically means they're separated by addition. These are multiplication. You can only cancel if they're both multiplication. Now, with a domain, now we've talked about finding the domain algebraically. That basically means setting this not equal to 0. And you're basically finding the cube root of that. 3 identical numbers that multiply to be 0. That number is 0. 0 times 0 times 0 is 0. So x cannot be 0. And when you're writing integral notation, that basically means negative infinity to 0. Don't include 0. And you pick any positive number.
Here you have the two letters F and G, so that's multiplication. So I'm going to put those in parentheses. When you have those, you're going to use your box method, or you can use FOIL. 2x squared minus 5, and then x minus 3. Remember, the order doesn't matter how you write those. And then you can just multiply those. 2x cubed, negative 5x, negative 6x squared, and positive 15. Now we're going to add or combine like terms. So 2x cubed, negative 6x squared, minus 5x plus 15, and your domain is negative infinity to positive infinity. Good question asked is, when does the domain change? Well, look at this next problem. When you do division, you have a rational function, and you now have to reconsider the domain. You're just going to put an F there, you're going to put a G there, you realize that you don't need the set of parentheses. You're not going to do something crazy. This would be wrong, like cancel x's there, because they're not factors. And so your answer is basically 2x squared minus 5 over x minus 3. But look at the domain. The domain, we said that you have to set the denominator not equal to 0. And when you add 3 there, x cannot equal 3. Well, you need to put it in interval notation. So a fancy way of saying not 3 is basically saying pick all your numbers from negative infinity to positive infinity. But when you get to 3, don't include it. That's what a parentheses means. And then union, or you can't pick 3, but you can go to positive infinity. So you would need both of those to get 2 points.
I had to divide to get it right. I'm really playing chess. I use my knight, can't fall behind. I got it right. Don't sleep in class, or you won't pass. I use my formula sheet, cause I don't cheat. I use it on my test. I'm feeling blessed, rose for Christ. You gotta come, remember in class, we don't chew gum. Get off your phone and pay attention. Not to mention, you're your detention.